Factors affecting biosorption. Biosorption is the process where biomass, including plant biomass and microbial biomass, bacteria, fungi, or algae, is used for the absorption of pollutants like heavy metals, synthetic dyes, or hydrocarbons. So, there are various factors that we need to study to understand the process of biosorption. If we know the factors which affect the biosorption process, the biosorption process can be made more effective. Biosorption is a promising and eco-friendly method for removal of pollutants, particularly heavy metals and synthetic dyes, from wastewater and other polluted sites like soil. The process utilizes the natural affinity of certain biomaterials such as algae, fungus, bacteria, and agricultural residues for contaminants. The efficiency of biosorption is influenced by various physicochemical factors which can be optimized to enhance the pollution removal from the environment. So this is one of the sustainable and crucial mechanism to remove all different types of pollutants from the environment. So first factor that influences biosorption process is temperature. Temperature mainly influences the kinetics and thermodynamics of the process. Temperature affects the kinetic energy of metal ions and dye molecules as well as the diffusion rate within the biosorbent matrix. An increase in temperature can enhance the diffusion rate and the availability of active sites by enlarging the pore size. However, excessive temperatures, that means more than 45 degrees Celsius, can lead to biosorbent degradation, which will ultimately result in reduction in adsorption capacity of the biosorbent. The effect of temperature on biosorption depends on whether the process is endothermic or exothermic. Endothermic is the process where there is utilization or absorption of the temperature or energy, whereas exothermic processes are the ones where there is release of the temperature. For instance, the maximum adsorption capacity for lead, that means Pb2 plus ions, was observed at 55 degrees Celsius, resulting in 84% removal rate. Conversely, copper, that is Cu2 plus ions, exhibited the highest adsorption capacity of 96.4% at 25 degrees Celsius. So temperature highly influences the rate of biosorption. pH is the another one crucial factor that will decide the rate and efficiency of biosorption process. Effect on metal and dye speciation. The pH of the solution significantly affects the solubility and ionization of metal ions and dyes, influencing their availability for biosorption. As the pH of the environment changes, the charges which are present on these metal ions or dyes as well as the charges which are present on the surface of the biosorbent will change. Most of the times, the charges play a crucial role in the process of biosorption. So, pH is one of the most important factors that will decide the rate of biosorption. At lower pH values, the increased concentration of H plus ions can lead to competition with metal ions or dye molecules for binding sites on the biosorbent. This will reduce the adsorption efficiency. Conversely, at high pH values, metal ions may precipitate as hydroxides and dyes may undergo hydrolysis, decreasing bioavailability and adsorption capacity. For getting any pollutant to bioabsorb on the biosorbent, it is required that the pollutant should be freely available. So if the pH value is high and these pollutants are getting precipitated or they are not being available, then the biosorption will decrease. So for biosorption to be successful process, there is a need for optimizing the pH values at which the biosorption will be maximum. Next factor is nature of biosorbents. Nature of biosorbent influence the biomass type and treatment. It includes some plant waste materials or bacteria or fungi, algae, Metal uptake can occur in various forms, such as biofilms, freely suspended microbial cells, or immobilized microbial cells can take up all these metals. These forms can be altered by physical or chemical treatments. Physical treatments include autoclaving, drying, boiling, sonication, while chemical treatments involve chemicals like acids or alkalis to improve biosorption capacity. So these treatments are given to the biomass prior to the process of biosorption. For example, fungal cells can be deacetylated, affecting the structure of chitin and resulting in the formation of chitose and glycan complexes, which are having more affinities than chitin. If the fungal biomass is treated in such a way before use for biosorption, the biosorption will be achieved with more efficiency. Additionally, factors like age, growth medium components, cell wall composition, cell size, and extracellular polymetric substances, that is EPS, formation by biomass can influence the biosorption efficiency. Surface area to volume ratio. Surface area is the area available for getting adsorbed, for the pollutant to get adsorbed on the biosolvent surface. Impact on adsorption efficiency. The surface area to volume ratio plays a significant role in efficient removal of heavy metal and dyes from the medium. A higher surface area provides more binding site for metal ions or dye molecules. If the surface area is more, obviously the process of adsorption will be more efficient. This property is particularly important in case of biofilms, where the binding of metal ions with the microbial cell wall has been previously reported. Although intracellular metal adsorption is an energy consuming process, microorganisms often prefer it over wall adsorption due to higher efficiency. Concentration of biomass. Effect on metal uptake. The concentration of biomass is directly proportional to the metal uptake. The main reason for this adsorption is electrostatic interactions between the cells and metals. Usually the cells have negatively charged groups on their cell wall surfaces and metals are positively charged. So there is electrostatic forces of attraction between these negatively charged group and positively charged metal ions. At the given equilibrium, biomass adsorbs more metal ions at low cell densities than at higher cell densities. However, an increase in biomass concentration or metal ion can restrict access to the binding sites due to crowding, potentially reducing adsorption efficiency. Therefore, optimizing biomass concentration is essential for effective biosorption. Initial metal ion or dye concentration. This is the concentration of the pollutant which is to be removed from the environment. It acts as the driving force for adsorption. The initial concentration of metal ion or dyes provides an important driving force to overcome mass transfer resistance between the aqueous and solid phases. Increasing the amount of metal or dye adsorbed by the biomass will increase with initial concentration. However, at higher concentrations, the biosorbent may become saturated and the efficiency per unit mass may decrease. Therefore, optimizing initial concentrations is crucial for maximizing removal efficiency. If the concentration is moderate, then the biomass can adsorb maximum of the pollutant in the beginning itself. But if the pollution concentration is very high, then surface area of the biosorbent may not be sufficient for adsorption of these pollutant molecules. So if we know the amount of pollutant present, then we can provide sufficient amount or sufficient concentration of the biomass to get maximum biosorption. Influence of pre-treatment. Pre-treatment is the treatment given before the actual process of biosorption. Physical and chemical pre-treatments affect the permeability and surface charges of the biomass. It makes the metal binding groups or the dyes more accessible for binding on the surface of the biomass. Pre-treatment of the biomass with alkalis, acids, detergents, and heat can increase the amount of metal and other pollutants uptake. These treatments enhance the biosorbent's affinity for specific metals, improving removal efficiency. Usually, these pre-treatments enhance the charges or they increase the number of charged molecules by some chemical reactions, and they may also increase the permeability of cell surface by increasing the pore sizes. So both these things increase the amount of pollutant getting adhered on the surface of the biosolvent. Pollutant affinity to biosorbent, this is also one of the crucial factors. Pollutant affinity refers to the attraction or binding strength between the pollutant such as heavy metal ion or dye and the biosorbent material, for example algae, bacteria, fungi or agricultural waste. High affinity means the pollutant is strongly attracted and readily binds with the biosorbent. If the affinity is low, there will be weak binding and reduced biosorbent efficiency. Factors that influence the pollutant affinity for the biosorbent include chemical nature of the pollutant. If the pollutant is having ionic charge, then it can be easily absorbed by the biosorbent. The size also plays important role as the smaller molecules can enter the pores on the biosorbent surface easily. The functional groups which are present on the surface or which are available to interact with the biosorbent are also important, as these functional groups can form some bonds with the functional groups or charged moieties present on the cell surface of the biosorbent. Hydrophobicity, that means the ability of a molecule to attract water, to hate water or to move away from the water or aqueous system, and hydrophilicity, that is attraction or affinity towards the aqueous systems. These factors are also important to decide the biosorption ability. Surface properties of the biosorbent, functional groups like hydroxyl, carboxyl, amino, sulfhydryl groups, all these groups play main role in the process of biosorption. If the number of functional groups is more on the biosorbent, the efficiency of biosorption process will be more. Surface area and porosity. If surface area and porosity are more on the biosorbent, it can act up as a better biosorbent and it can attract more pollutant particles. Also, surface charge, which is usually pH dependent, plays main role in the process of biosorption. And there are certain environmental conditions like pH that affects both the ionization of functional groups on the biosorbent and also speciation of the pollutant. Temperature can impact the kinetic energy and interaction strength between the pollutant and the biosorbent. Ionic strength of the competing ions may interfere with the binding. So all these factors play a crucial role in the process of biosorption. So in conclusion, we can say understanding the interplay of all these factors is crucial for optimization of biosorption process for the removal of heavy metals and synthetic dyes from wastewater and other polluted sites. Experimental studies including kinetic studies, thermodynamics and isotherm analysis are essential for elucidating the mechanisms and optimizing conditions for effective removal of pollutants from the environment.